So we want to prove that this equation holds true. Now, you know the definition of absolute value. What I want you to see is that this x, all these x's, it doesn't have to say x. Like we could change all of these to like p's, q's, w's, or we can also change this to a different quantity like this. So you see how this definition is not really limited to just one piece. It could be two components like xy. That's a product. xy, all these become xy's. So I want us to look at this definition here for the most part. Now, we have two cases, xy greater than or equal to 0 and xy negative. Let's look at the first case first. So xy greater than or equal to 0 up here, that means that the absolute value of xy is just xy without the bars, like that. But think about what this means. If x times y is greater than or equal to 0, then that means that both numbers are positive, or both numbers are negative, or both numbers are 0. So we have three different cases. The first case, let's suppose that x and y are both 0. So we know for sure that this is true. That equals that which is here. But under this first case, x and y are both 0. And so x and y get turned into 0, which are equal to the absolute value of 0, and which gives us an opportunity to turn the zeros into x and into y. And that's good because we've split up the absolute values to get what we want. You see that? So we've proven what we've tried to show, but that's just one case. The case where x and y are both 0. Now, let's consider the next case. Now let's pretend that x and y are both positive, which makes sense because x times y has to be greater than or equal to 0. Now, if x and y are both positive, then this is what we have. So if x and y are both positive, then the absolute value of x is just x itself because it's already positive, and the same goes for y. And now let's look at the main thing that we have to work with up here. Then under this case, x and y are both positive, so we have these little mini equations, and by substitution, this x turns into that, and this y turns into that. And we're done, right? Because we have xy in the bars equals the bars split up. Yeah, so that covers this case. So again, we've proven the main thing under case 2. But now there's a third case. Now the third case is x and y are both negative. Because if they're both negative and you multiply, it gives you back this. So this is being respected in all three cases. But now if x and y are negative, here are the little small mini equations. So when x and y are both negative, then the absolute values are equal to the opposite of the number itself. Because x is a number that's negative, and the double negative would knock out, which is what this would give us anyways. But now you know what we can do? We can manipulate these guys. Let me kick the negative over to this side. So now I have these smaller equations to play with, but now let's go back to our main piece of information. So this guy is right here, but then x and y can be individually replaced by that and that. So x and y turned into this and into that, and these double negatives knock out to give you that. From here to here, that's property 6. I'll say it again. From here to here, that's property 6. And like yet again, we have proven the main thing. But notice that these three cases are only under the assumption that xy is greater than or equal to 0, which is this one. But now we have to quickly look at the bottom case, where xy is negative. And when xy is less than 0 or negative, the absolute value of xy equals negative xy, the bottom row. So now here's what we have to work with. Now think about this. If x and y are negative, if the product is negative, then that means that exactly one of them is negative. They can't both be negative because then the product will be positive. So only one of these is negative. Maybe x, maybe y. Just pick one really. So let's just pretend that x is the positive and y is the negative. And that makes sense because the positive times a negative, xy, the product, would be negative because it's less than 0. And since x is positive, x equals its own absolute value. And since y it's negative, the opposite of the absolute value equals y. That negative would have appeared there originally, but I just moved it to that side to, save us some time. So now let's write down the main equation that we have to work with. So keep everything the same. The negative is still there, but now x turns into that and y turns into that. And again, by property 6, this gives us the following. And we really don't have to do the other case where here was x positive, y negative. You don't have to show the case where x is negative and y is positive because it's exactly the same, and professors understand that. Just give them a quick sentence that says that, hey, you know what? the case where these are backwards, it's the exact same thing. We really don't have to go through the trouble of showing that because it's the same thing. So, in summary, this proof had two major parts, the top part and the bottom part. The top part broke up into three smaller subcategories, and the bottom part had one major component to it. So the desired proof has been provided.